As said, this is a Raspberry Pi. It's a $25 computer, and I'm going to plug it into this 5 volts USB cable that I had spare from my broken phone, and also to the screen here. And it's booting into a Debian Linux system, hopefully at least. Basically, it's reading the system from an SD card. Can we get the video, or? Oh, we don't get the video. Well, it's believing that it has video. It was working fine. This is like the pattern of tech stuff not working, it seems. Let's try again. At least this cable looks good. Let's try again. Ah, perfect. So it's booting into this Debian Linux, reading it from an SD card. My name is Thomas Kroeber. He mentioned that already. I'm working at Nokia, and actually on automotive. It's pretty unrelated, but it's embedded technology as well. I'm trying to put JavaScript into cars. But that's the first step. So the Raspberry Pi. Well, let's start this way. So when I grew up, learning to program was actually connected to wanting to play computer games. Let me quickly. So I had a ZX81 computer, and there wasn't, like, you couldn't really go and buy games for it. So what I had to do is get these magazines, copy the code of the games, and then compile them and run them on the small computer. And I learned programming because I wanted to play games. And that pattern that worked for me, I mean, when I went to university, I had mastered 3 programming languages. There wasn't much programming that I could be told, at least in the early semesters, and that was a pattern, at least in my generation, of a lot of people that went to university to study computer science, but they could already write code. Now, if you look at kids today, the gaming has moved to these gaming consoles, and these gaming systems, by design, are designed as closed systems. You can't really easily write your own code for them. You can't really fiddle with the electronics in them and so forth. So that opportunity for me to kind of learn to write code because I wanted to play games is not there for kids of our age. And according to this gentleman, Eben Upton, who's the co-creator of the Raspberry Pi and also works at Cambridge University, you can see that in the applicants at university for computer science. So the numbers have gone down for him, and I don't know if that's a global pattern or just Cambridge. And also the knowledge that students have at university, or the pre-knowledge that students have at university, has went down. And what he started to do is think about, okay, how can I create a computer that is cheap and easy to use for children, that they can use to fiddle around? So something like the child's bicycle compared to the family car. So you can't really, like, or you don't really want to break the family PC to the kid, like, to learn programming or anything, or learn how to install Windows and so forth. And that is kind of the idea. The Pi is in pretty early stage, so I'm not sure if it is yet that thing for children to do, but at least you can see things like this. So this is like a child building a case for the Pi. Actually, I don't have one. So that's kind of fiddling they are looking for. If you look at the Pi, that's the board. It has pretty much everything you need to connect it to a TV. So it has this HDMI plug down there. It has an S-video if you have an old school TV. It doesn't have VGA, which was like some trouble to connect it here, but it worked finally. It has audio. It has, at least this one, which is actually $35, has a network adapter as well. The cheaper one doesn't have it, and it has USB. the CPU of this is, well, for $25, you can't really expect much, but it's this thing. It's an ARM11, and it's like clocked at, I think, 700 megahertz or something like that, which is like ARM11. I don't know how much you know about embedded, but it's a relatively slow CPU. It's like at the range of like pre-iPhone 1. But the CPU actually, if of that, like, well, it's like, I think 12 by 12 millimeter size on there. Of that 12 by 12 millimeter size, 2 square millimeters only are the CPU, and the rest of that thing is actually a GPU, which is pretty powerful. So it can do full HD in 60 FPS pretty much on that small thing. And actually the presentation that you're seeing is running on that thing. And it is actually rendering it in full HD. It's just scaled down because that system can't do full HD. So it's like it's a pretty performant GPU, but then if you do a lot of things on the CPU, it's not as great. But you can run X Windows on this. You can run Mozilla on it. It's just not as great as this stuff. So what I'm using to get JavaScript on this is Qt, which is actually a C++ framework. It's pretty old, like 20 years, but it's been evolving over these 20 years. It's open source, and it has for instance, WebKit. Like Apple at some point took WebKit out of the Qt framework, like I don't know, 10 years ago or whatever. So it's the root to many systems, but it's been evolving. And the latest version that I'm using is Qt 5, and that has undergone like a complete rewrite of the graphics pipeline. So everything is put onto the GPU. All the objects are basically textures, and they actually went away from using C++ to define the UI and into something called Qt Quick, which is actually a UI markup language that is built looks a little bit like SCSS. So it's not XML based, but it's essentially still a tree. It uses JavaScript for scripting, and it does that different than what HTML does. So really, all the nodes in there are basically, you can put JavaScript code, or actually they are JavaScript. At least all the values are essentially JavaScript. In addition to that, also different to a browser, the elements, there's no sandboxing between the markup / scripting world and C++, so you can very easily build something in C++ and then expose it into QML, which is QML, by the way, is the markup language of Qt Quick. And there's other nice things like shaders and like a HTML5 canvas and particles and stuff like that. So that's a very simple QML program. What it does is create a rectangle with a pink color at a width and a height, and you can, as said, like all the things to the right of the columns are actually JavaScript, so I can do width times 2 here, or whatever, math pi times width, which is going to be big, something like this, or 1.2, 1.5 times width. So what was that? Like this, or just square it with width. You can, to define the markup, you can then like add nodes as children. So let's put a text node there. Oops. Some text. JS. And make it a little bit bigger. Color it white. And then we can anchor it to, like, so basically use anchors to position things. So if I anchor this to the parent right, then it should anchor the right of it to the parent right. Anchor right, parent right. It should be on the right. Well, let's see. Anchors. Oh. Why doesn't this work? Well, don't need that anyway. This is the benefit of live coding. So, okay, so there's other properties. Whatever, we can put the radius there. Radius there to give it round or corners, or we can rotate it. 30 degrees. You can also, instead of just putting numbers there, you can put animations there. So we can do something like number animation on rotation from 0 to 360. And then probably let that run a little bit longer. 3 seconds. And it loops. And have it loop forever. What else did I want to show? Let me check real quick. Yeah, that's cool. We quickly go a little bit into JavaScript here. So, for instance, I could like these. All these properties are bound on. So let's give if you give an ID to an element here, it actually becomes an object in JavaScript. So this is my text, and then I can say here. Oh, I don't need that actually. Anyway. I don't need my text, but I might. So you can even if things are animated, the property bindings will apply to those, and you can even put a function here. So in QML you can just leave away the function keyword because they don't get parameters because they're basically just supposed to return values. So you can also put return a value here, or do things like again like 10 times the rotation. And again, like in Qt Quick, it's like observing all the properties that are changing, and then whenever something changes, the JavaScript is reevaluated. The engine inside there is V8, of course. Yeah. Okay, so that's like at least a simple Qt Quick program. You can also put shaders there. So this is a shader that actually has commented most of the code out. Why is that? So I think most of you heard about shaders, but basically it's like it's similar to the stuff you get in WebGL. So it's GLSL that is built in, and you can just for a node again, like this shader effect is a node, a special node that allows to have a shader. There's like a property that I'm defining here, which like again you could define properties that have types which are becoming available in JavaScript, but also in the shader. So this property is a real value of time that I'm using here in the shader. And then there's like this Qt specific text chord property which is exposed into the shader, which gives the pixel of that should be rendered, at least for the fragment shader. The fragment shader is essentially a small program that is run for every pixel in the screen. So for a full HD, it's like 1920 by 1080 by 60 as it's running at 60 frames per second times per second. So it's like 120 million times or something like that this is run. And at the moment, it's just like using the X and Y position to create a color, like for the red channel and the green channel of the color, and then blue is left black, and then there's 50% opacity on it. So instead of that, let's just enable this code because I didn't want to write it myself. So let's put this out. So this is just to show what you can do with like shaders. So this is essentially just a couple of sine curves, like put on the screen with gradients. So you can look like there's a sign here that uses the time again, which is a number animation up here. So if we decrease the duration, it should run a lot faster. And then there's a value computed out of the two positions, which is becoming the color once we apply a square root on it. This is actually like a slightly modified example I found on some WebGL page. Okay, so let's get to the more interesting stuff. So in addition to this GPU and the capability to run like Linux on it and programs for Linux on it, this thing has also GPIO pins, and you just heard about them in the talk before lunch, or most of you have. So it's essentially these are programmable pins that you can like set, make like 3 volts voltage on or no voltage, and you can just put stuff on them. So you can have LEDs blinking, you can have serial communication. There's like IX2C, which is another like communication protocol for like these embedded devices or microcontrollers. And you can also read data, and you can generate analog curves for data to like create audio or things like that. So again, like these things are pretty much just exposed on the board. There isn't much usage on them yet, but at least people have been started building things around them. And at the moment, it's really easy to toast the board with them. If you just get them like short circuit something or give them too much voltage, you'll fry the pie. And there's like another open source project to build a device that you can plug on that like makes this more secure. And I haven't gotten that yet. So I actually, Friday was my Friday. I fried 2 pies. And then went a little bit panicked because those were my only 2, and yeah, I had this presentation coming. So, and actually, now I have to go here. So, this thing here is like a nice sandwich that I built to protect the pins. It's too ugly to actually explain what it's doing, but basically, it's like reducing the voltage, and I'm just going to put this on here real quick. And then first thing I want to show is just like how to control a simple LED with the pins. So it's just this is an LED, and I want to give it power. That's here. This is actually supposedly a very bright LED, so if you look into the light, you will die. But maybe it's bright enough here that we can try. This is actually not yet the thing I want to show. So let's just quickly get a shell here. So this again, like, is like a pretty much a shell written in QML and JavaScript and some C++. You can also see the. Can you see this? The particle effect there, another QML feature that you can add there. It's a little bit crazy, but anyway. So what I would hope happens now if I do to see detect. Yeah. So it found my my LED. So let's just switch this, initialize this real quick. Okay, so it's black. So now we can start. So what I can do with this LED is like just send RGB values to it, and it's a little bit fragile, so I'm not gonna. But basically, I wrote this small script, which again is using shell. Like there's commands that come with Linux to just communicate with it. So let's look at this. Oh. RGB. So it's this simple shell script, which is just this I2C set command is really crazy, but basically it's just taking an RGB value and then puts it on the right, formats it right, so the I2C set up there can be called. So if I do this fade RGB, I should now be able to give it a RGB value. So let's say we want to have red. That's not working. Oh. As you can see, the red is glowing, and then you can have other things like, let's say, white. And then, well, this white is actually like, it's 3 LEDs. I don't know. Well, this can be seen, but it's basically adding these up. So this is nice, but then we don't really. It's like I'm using the shell. I'm not using JavaScript, so it's a little bit boring. So let's try to get to expose this stuff into JavaScript. So this is, or to QML actually, I should say. This is what you have to do basically. There's one class that you have to write, which is creating an item in the Qt Quick world, which is this, I'm calling it GPIO. So it's extending a Qt Quick item. It's like there's some boilerplate QObject stuff that you have to add, which is just giving this like introspection, this class, C++ class introspection capabilities. And then there's a constructor, and this digital write function up there is actually the function that calls, that does the system calls to write something to the GPIO. Which is like, I found that in the documentation for this chipset. And then another class you have to write, which is just this plugin down there, which creates a plugin for QML and registers the GPIO type down there under the name GPIO. So the second thing you would only have to do once per thing that you want to expose. The others, the classes you would have to write. And then if you, this QInvocable actually tells it that this function should be invocable from the Qt Quick JavaScript world. You can also add properties to these items and do more things, or like do the inverse direction. But just for this simple thing, this should allow us to write stuff. And now I'm not going to compile this because it's going to be too nasty. But basically, the idea is to use this for something more. And since this thing was made for kids, I thought I'd go into a toy store and bought this small thing to play music, and then build this thing, which is like a bunch of like electromagnets with small hammers. They're called solenoids. Basically, it's a coil that like draws current on a like this hammer, and then pulls it down if you apply power to it. And if you don't apply power, there's a small spring that pulls it back up. And this crazily great woodwork actually fits perfectly on my instrument. And then these wires actually go to this thing. The thing with these coils is that they actually draw a lot of power. So these run at 24 volts. Actually, I should put it this way so you can see it better. So no way to like power it off the 3 volts that you get out of the Raspberry Pi. And if you try, or if you make mistakes, then you have a Raspberry Fry, which I don't suggest to do. So instead of that, I have this like old notebook power adapter here that should power them, and then there's this insulation circuit here that should like basically there's like a Darlington switch that like allows to power a lot of power to run through without harming the pins. So this is all powered. Then we have to wire this to the Pi. where did I put that? There. Okay, this we don't need anymore. Now, let's think. So, if so, I have this GPIO element, and there's a well, we just saw that there's a digital write function that allows to write, like set a pin to high or low. So this is just like my first song. So what I'd like to have is like this function. I would want to call this function, or I want something to call this function, and then run through this song here, which is just a bunch of nodes, and then the space character should. Why is this space thing so? The space character should say like, okay, there's actually nothing to play. So the idea is have something that every whatever second iterates through this string and then looks at what is the current node and then plays that. Now in QML is like it has JavaScript, but it doesn't have all the things that the browser has. So timers are one of the things that are done differently in Qt Quick. And the way they are done is that you just add a timer there that has an interval. Let's say we want to play every 200 milliseconds. I want to iterate every 200 milliseconds. And then should actually be repeating. And then there's a function or a signal that is called, which is on trigger, and that actually does like trigger whenever the timer hits. And this actually should just be our play next call. Okay, so now we should have a timer that halts this function, and then this function should play a tone. And now, if I set this, let's actually do this. Just do. So if I set this pin map, hash map there, array there, just maps the nodes to the pins on the pie. So I want to have AC, and then set that to 1. Let's put this away for now. This as well. So I make this running. What was that? Oh. Oh, thanks. Let's look. Something's wrong. It's like not a very decent way to kind of debug, but oh, okay. Control C was not a good idea. Okay, let's start from scratch. How much time do we have? So again, we need a timer. On triggered, it should call play next. And let's use my notes here. interval is 200. It should repeat. It should be running. Let's use this later. And then, since this should work. This won't. Let's take these out for now. I just want to get this thing hammering at least once. So you see this, and I'm kind of confident that it works. So now GPIO digital write. Oh, 9. Okay, so impressive, isn't it? But that's basically now, I wrote a 1, but that 1 remains set, and it's not going up again, and that there's no real tone. So if I send a 0 again, it goes up again. So what we have to do is have something that actually moves the hammer down really quick and then moves it up right away. So and that one timer won't really kick it because we don't have, well, it's JavaScript, so it's event driven, so we don't have a delay function or anything. So we need another timer, and then that timer should just run really short. So let's say 1 millisecond. Oh, sorry. Okay, let's do this in 2 minutes. I'm gonna be quick. I'm just Q mission. No, this is gonna be better. Maybe not. Yeah. Okay, I'm gonna run. So we want this, and then on triggered. We want to digital write. I'll delete the node that I had, and then a 0. And the node, we don't really, well, kind of we have to pass a parameter into this. The best way to do this is probably just by adding a property here that is accessible, and then give this an ID. Node, no, okay. Node is written differently. Now we should at least have this. Let's check. Okay, looks good. Something's wrong. I guess I won't get this working in time. Okay, so let's just imagine that it works. It was working, but I just don't get this. And I don't really have a backup that I could just put in and have playing, I think. Or do I? Actually, I do. Okay, so if we have at least 10 more seconds, let's quickly, just to show that this can work. not. Okay, maybe not. I'm sorry. But then if you want to play music, check out Raspberry Pi.
Awesome.
Yeah.
Live coding, which does not kill us, only makes us stronger.
Yeah.
Maybe you could, is it possible you could even take this entire setup outside and
then, yeah, we
and
can.
Like people during the break, we got a break coming up in 2 more presentations, maybe.
Yeah.
All right.
Let's
So
do that.
demo
Okay.
to be continued outside. All right. Cool. Thank you very much.